In this video, we're going to prove a few facts about the sigma function and powers of 2. If you're into seeing mathematical proofs, then you should consider subscribing to my channel, as this is all I do on this channel, is I prove mathematical facts, theorems, lemmas, corollaries, etc. The first fact that we're going to prove is that n equals 2 to the k minus 1 satisfies this equation. So, proof of A. Now, sigma of 2 to the k minus 1. This is going to be, well, the prime factors are 1 and 2 and 2 squared, all the way up to 2 to the k minus 1. And if you happen to add all these numbers, you get 2 to the k minus 1 plus 1 minus 1. That is, you get 2 to the k minus 1. 2 to the k minus 1. But that's n. So 2 to the k I can think of as 2 to the k minus 1 minus 1. So that's n. 2n minus 1. Done. Let's get rid of our side work. Proof of B. B says that if k minus 1, 2 to the k minus 1 is prime, then this value of n satisfies that equation. Okay. So, let us consider sigma of n, which is sigma of 2 to the k minus 1 times 2 to the k minus 1. Now, this is an odd number, because 2 to the k is even. Take away 1, you get odd. And this is only powers of 2. This has no fact divisors of 2. That is, their GCD is 1. And if their GCD is 1, we're allowed to separate them. Just want to formally state that the GCD of 2 to the k minus 1 and 2 to the k minus 1 is 1. So this is sigma of 2 to the k minus 1 times sigma of 2 to the k minus 1. Now, in part A, we actually talked about that one. That's 2 to the k minus 1. So this is equal to 2 to the k minus 1. Now, they told us that 2 to the k minus 1 is prime. That's prime. So sigma of a prime number is that number plus 1. So basically we have 2 to the k minus 1 times 2 to the k. Now, we want to show that this is 2n. So n is this, 2 to the k minus 1, 2 to the k minus 1 times 2 to the k minus 1. That's n. And we're supposed to get back 2 times n. Okay, if you multiply that, you get back 2 to the k times 2 to the k minus 1. But that's exactly what I have here. So I can factor out, or 2. Well, okay, equals that. I already factored out the 2. This here is equal to this. I factored out a 2. And I got back twice n. I got back 2 times n because that's n. Part C says that 2 to the k minus 3 is prime. And they're saying that this n has the property that sigma of n is equal to that. So let me erase my proofs and let's go from there. Okay, so proof for C. Sigma of 2 to the k minus 1 times 2 to the k minus 3. That's even. You take away 3, it's odd. No odd number has a divisor of 2, but this does. So once again, since the GCD of these two numbers is 1, I could separate it. I can take sigma of 2 to the k minus 1 and sigma of 2 to the k minus 3, and I can multiply them. Well, I think we found sigma of 2 to the k minus 1. Okay, sigma of 2 to the k minus 1 is 2 times n minus 1. It's 2 to the k minus 1. And again, the reason is the prime factors of those of 2 to the k minus 1 is 1 and 2 and 2 squared and 2 cubed, all the way up to 2 to the k minus 1. So when I add all those factors, I get 2 to the k minus 1. So it's 2 to the k minus 1 times sigma of a prime number. But prime number only has 2 factors, 1 and the number itself. So it's 1 plus the number itself. You have 2 to the k minus 1 times 2 to the k minus 2. 1 plus negative 3 is negative 2. Let's get rid of our side work. Okay. Now, this here is equal to, foiling it out, this is 2 to the 2k minus 3 times 2 to the k plus 2. Now the question is this 2 times n plus 2? Well, let's see. 2 times n, 2 to the 2k minus 1 times 2 to the k minus 3, that's 2 times n plus 2. Well, distributing, that's 2 to the k. Actually, let me multiply what's in the brackets first. This is 2 times 2 to the 2k minus 1 minus 3 times 2 to the k minus 1 plus 2. But that is so this top line is 2n plus 2. And if I distribute the 2, I get 2 to the 2k minus 3 times 2 to the k plus 2. But that's exactly what I got. So basically, if you wanted to continue from this line here, just go up. This is the same as, so I factor out a 2 times 2 to the k minus 1, 2 to the 2k minus 1, minus 3 times 2 to the k minus 1 plus 2, go up to the top line, and we'll get the following. This is 2 times, so I factor out the 2 to the 2k minus 1, 2 to the k minus 1, and what's left is 2 to the k minus 3. Don't forget the plus 2. But this is 2 times, oh, that's n, plus 2. So I'm just going to erase this because now I have a cleaner proof. All I did was read it backwards. If you like watching mathematical proofs like this, definitely consider subscribing to my channel, because that's what we do on this channel. Click the like button, tell your friends about my channel, subscribe. See you guys in the next video. Watch and learn.